In this video, we'll be discussing about email backscatter attack. Email backscatter attack is a type of attack where the attacker is taking advantage of the NDR functionality of an SMTP server. Its main objective is to do a denial of service in the target. For us to understand its concept, let's dive in first on how NDR works. Bounce message, non-delivery receipt, non-delivery report, delivery status notification, and non-delivery notification are all the same thing. It's an automated message which informs the sender that the message has not been delivered due to some issues. We have two possible types. One is called the soft bounce and the other is called hard bounce. The difference is that soft bounce are temporary. It could be mailbox of the user is full or the host is temporarily unavailable due to some connectivity issues. On the other hand, we have hard bounce, which is a type of NDR dealing with a permanent error. The most common one is the mailbox doesn't exist. As a rule of thumb for the brotherhood of SMTP servers, accepting the message means that you are accepting the responsibility for sending an NDR in case of undelivery. Okay, now let's try it. I have labeled the SMTP servers from figure 1 to figure 6. Let's say for example that SMTP server 1 were tasked to send an email to SMTP server 6. Okay, so it will jump in from 1 to 2, from 2 to 3, from 3, upon establishing the connection, SMTP server 4 noticed that SMTP server 3 is under its blacklist. So, upon establishing the connection, SMTP server 4 sends a temporary error. So, let's say it's a temporary blacklist. So, that's 4XX. The question is, who will be the one responsible for sending an NDR to the sender? That's right, it's SMTP server 3. Because SMTP server 4 didn't receive the email at all. Okay, now let's say that the blacklist from SMTP server 4 has timed out. So let's say server 1 were tasked to send an email again to server 6. So the same thing happened. It jumps from server 1 to server 2, server 2 to server 3, server 3 to server 4, and server 4 now receives the email because server 3 is not blacklisted anymore. Then it jumps in from server 4 to server 5. Then we have server 5 to server 6. Now, from server 6, it noticed that the mailbox of the recipient is already full. So, the same question, which server will be the one responsible for sending an NDR? You're right again, it should be server 6 because SMTP server 6 already received the email. Okay, now let's try another one. Let's say SMTP server 1 will be sending an email again to SMTP server 6. And knowing that SMTP server 4 has been removed from the network. Let's say there's something happened to SMTP server 4. Okay, so the message will be sending from SMTP server 1 to 2, from 2 to 3. But upon sending message from SMTP server 3 to SMTP server 4, it cannot be sent because the server is down. Okay, so SMTP server 3 will determine that the host is not reachable. So the question is, which will be the one responsible for sending an NDR? Obviously, it is SMTP server 3. Because it is the one which lastly received the email. Okay, now for the last one. Let's say SMTP server 1 will be sending an email again to SMTP server 6. So the same thing happened, SMTP server 1 to 2, 2 to 3, 3 to 4, 4 to 5, and let's say the message has been successfully received from SMTP server 5. However, the scanner found out that the message is a spam. So the SMTP server 5 put the message under quarantine. The same question: which will be the one responsible for sending an NDR? On this case, by default, SMTP server 5 will not gonna be sending an NDR. In fact, no NDR will be generated in this scenario. Now that we already understand how NDR works, let's see how an attacker can do such attack scenarios. Given here an attacker and two MTA servers, let's say abc.com and gmail.com. By the way, I've choose gmail.com because I've seen a lot of MTAs or SMTP servers blocked by Gmail because of a backscatter attack. Now let's say the target is abc.com, and for some reason the attacker has identified a way on how abc.com can send an NDR. So the attacker will create a message, let's say mail from user@gmail.com, and abc.com, without having a domain authentication, it will accept the mail from command. Then the attacker continue to send RCPT2 the data until the message has been successfully transferred to abc.com. Okay, but however, at some reason, abc.com need to send an NDR to the sender. So since the sender is from gmail.com, the NDR will be sent to gmail.com. And of course, Gmail accepted the NDR. But the attacker do it again and again and again and again until such time that abc.com has been blocked by the gmail.com. So let's say for XX, just a temporary blocking. On this case, the attacker has successfully denied some part of the service of abc.com, and that is sending an email or message from abc.com to gmail.com. Okay? But of course, the attacker won't stop there. It will be sending another email from a different domain until abc.com has been blocked to multiple domains. In that case, abc.com will be denied on most of its services. Now, some might ask, can we just disable the NDR? That is to avoid a backscatter attack? The answer is, yes we can, but don't. As designed, the intent of NDR is to notify the sender. And for me, it's actually the rights of the users to be informed when their message doesn't arrive in its destination. So as a recommendation, do not disable NDR. Instead, enable backscatter protection from your gateway. As an alternative option, we can also enable Sender Policy Framework, or SPF, which is a type of domain authentication usually implemented to avoid domain spoofing. Now, there are a lot to discuss about SPF, so we'll just be doing it in a separate video.